Hey, this is our second activity on buoyancy, and this time I am using clay. I had two clay balls. One I kept as a tight ball, and the other one I flattened out and gave it a little bit of a curve just to see if I could get it to float. So I'm going to put this in the water. Oops. And I'm going to put this one in the water. And notice that the clay ball goes right to the bottom. And I'm going to bring the camera back down and show you the difference between the two. So I can change the density of that clay just by changing its shape. That's quite interesting, isn't it? They both have the same amount of mass, but now they have a different volume. Okay. And so because they have that different volume, because of the surface area that they cover, that changes the density. So let me show you that with definitions and the formula. So I'm going to kind of bring this up and change this around a little bit. There we go. So mass is the amount of matter that's in an object, and volume is the amount of space that an object takes up. Okay, so in the clay, in both the clay and the foil, I was able to change the volume. The foil doesn't see as huge a difference because it's so significantly small. It's it has a lot less mass than the clay. The clay has more mass, so you're going to see a difference. And when we look at the difference, it's called density. So the amount of the mass in a known object is called the density. And density has a formula, and the formula is D equals M over V, or density equals mass divided by volume. So if you know the volume of something, and we did that last week with displaced object, where we put the object into a graduated cylinder and measured the volume. If you can do that and you divide that into the mass of the object that you measure with a balance scale, you can figure out the density of an object. Okay. And the other term I talked about here is surface area. Surface area is the total measurement of the area covered by the object. So the larger the surface area, the greater the buoyant force acting upon it. So I had buoyant forces pushing up on the clay that I flattened. I had a lot more buoyant forces pushing up and gravity pushing down. Well, on the ball, all the gravity was pulling down, right? Because gravity is measured by weight. And the buoyant force only could push up in this one little area. So that's why it sinks. I hope that clears up buoyancy a little bit better.